So we are going to spend the next couple days graphing things. Today we're going to learn how to graph sine.
Hate graphs. Sorry.
All right, so the x values that we're going to use, the thetas that we're going to use are 0, pi halves, pi. What do you think the other two are? 3 pi halves, 2 pi. So we are looking on the unit circle, and we're going around this way. We're just looking at all the quadrants. Now, if we are doing a sine graph, the first one we're going to do is sine of 0. Can somebody look at their unit circle and tell me what sine of 0 is? 0. Then we're going to do sine of pi halves. That's 1. Then we're going to do sine of pi, 0. Sine of 3 pi halves,
-1.
and sine of 2 pi, 0. The reason we use these values is because we're lazy and they're easy to graph. That's why we use these, okay? We're just being lazy. All right, you do not need a marker for this. I'm using a marker so you can see it on the screen. You are welcome to use a marker if you want, or highlighter, or whatever, colored pen. So I'm just drawing my x-axis and my y-axis right as close to the middle as I can get it. And what I'm going to go ahead and do is on the x-axis, I know that my x values are in terms of pi. And I'm going to count 1, 2, 3, 4 boxes and put pi. And then I'm going to count 1, 2, 3, 4 boxes and put 2 pi. And I'm going to go backwards and do the same thing. So 1, 2, 3, 4 and put pi. 1, 2, 3, 4 and put 2 pi.
So are we just marking the graph right now? Or is it
Yeah, so we haven't started graphing anything yet. The important thing about these graphs is that your x and your y-axis always have to have intervals labeled because you're going to change it every time. So this is not like when we graph lines and we always go by ones, and so we don't really label it because everyone does it the same. This is where every single time you truly will change your labels, and so we have to label it every time. Okay? How big does the y have to get to if you look at your table? Yeah, +1, and then how small does it have to get? -1. So it doesn't matter on the y-axis what you go by. I'm going to go ahead and just put 1 in the middle. All right. So now we're going to go ahead and plot these points. We have the point 0, 0, right there in the middle. We have the point pi halves and 1. Where do you guys think pi halves is going to be? Yeah, it's going to be to the right too. It's right in the middle of 0 and pi. So pi halves and then go up 1. Then we have the point pi 0. So go to the right pi, don't go up or down at all. Then we have the point 3 pi halves -1. Where's 3 pi halves?
2.
Yeah, it's right in the middle of 1 and 2. So that's at -1. And then the last we have 2 pi 0. Okay. Now, the part that we have to pay careful attention to, do not draw this. I'm going to show you the wrong way. So this is the wrong way, don't draw it. A lot of students will start connecting these like this because these are the only points that I had them draw. So what we're actually going to do is we're going to look at some other values that are on the circle. So if we think about what happens at pi fourths is going to be this line right here. It's 1 box out of 4. Pi fourths has a y-coordinate of √2/2, so that's what the sine value is. So if I look to see what √2/2 is, square root 2 divided by 2 is the decimal 0.7. And 0.7 would be right here. You guys see that? Does it look like the line goes through 0.7? No. So these graphs actually don't go straight. You don't connect those dots in a straight line. You actually draw what kind of looks like little bowls. This is how we connect our dots.
Kind of like mini parabolas.
Yep, kind of like mini parabolas, exactly, yeah. So what I always tell students is you cannot make a graph that looks like Charlie Brown's t-shirt. You know what I'm talking about?
No.
He has a yellow t-shirt, and then it has like a chevron, like a brown chevron on the front. So we do not want to make our graphs look like Charlie Brown's t-shirt. Okay, so here is the pattern. We're going to draw a little sketch of a sine graph so we can remember what the pattern is. The pattern is I start at 0, I end at 0, I hit 0 in the middle. Do you guys see that? Start at 0, end at 0, hit 0 in the middle. Okay. Between the first 2 points, I go up to 1. Between the second 2 points, I go down to -1. That's the pattern. So for every time we're going to draw a sine graph, we're always going to think of it that way. Now, this right here is called one period of the graph because we got all the points from going around the circle one time. So up here, we're going to write that one period of the graph is 2 pi. And they call a period one cycle, like we just did one cycle of the graph. And this does not have anything to do with health class, even though it sounds like it. No, ladies?
That was fun.
Okay. So we're going to draw another. We're going to draw another cycle of the graph. We start at 0. We end at 0. We hit 0 in the middle. Between the first two, we go up to 1. Between the second two, we go down to 1. So typically math teachers are going to ask you to draw 2 full cycles of the graph so that we can see that you actually understand that the pattern repeats. It keeps going. All right? And you'll notice I have arrows on either end because this curve would continue to go up and come down and go up and come down and go up and come down. All right, this line that cuts through the middle of the graph, in this graph it happens to be the x-axis. It won't always, but for today it will. This middle line is called the midline. So the middle line is called the midline. That's the midline of the graph right there. I'm just going to go ahead and label this right here. That's the period. So it's how far it takes to do a full rotation. It goes up, it goes down, it comes back to where it started. It goes up, it goes down, it comes back to where it started. And then we have one more vocabulary word, and that is amplitude. The amplitude is how far you go up or down from the midline. So this is the amplitude. And this is the amplitude. So how far did we go up and down from the midline? 1. So the amplitude for this graph is 1. Okay. What's the domain of this graph? Yep. Negative infinity to positive infinity. And what is the range? Yeah, -1 to +1. It goes down to 1, it goes up to 1. Should those ones have brackets or parentheses? Brackets. Why are they brackets? Yeah, if you say, Miss Rice, where is it 1? I can say it's 1 right here, and it's 1 right there, and it's going to be 1 over here, and here, and here. It's going to continue. Okay. So that's sine graphs. We're going to skip the bottom of this page because we're going to do cosine graphs tomorrow. Okay, so go ahead and turn to the next page. We have y equals a sine b times x minus h plus k. So these letters are somewhat similar to what you've seen before. You guys have seen the a before. You've seen the H and the K before. The one that's different is the B. You have not seen that before. The rest of them are the same. So these last 2 transformations, these should be pretty easy for us. What does the one in the parentheses tell you?
Left or right?
Left and right. And what type of numbers move you to the left?
Positive.
Positive.
Sorry.
It's okay, I got you. And then what type of numbers move you to the right?
Negative.
Negative. How about the number on the end?
Up or down?
Up or down?
Positive.
And positive moves you up and negative moves you down. So those are transformations we're going to get to, but we are not doing them today. We are not going to focus on those. Okay. The one that we are going to focus on is this one in the front. What does that normally do for graphs?
Stretch or compress?
Yeah, stretch or compress, right? So if you take a graph, you do not have to flip the page, but if you stretch it, it would make it like taller or shorter. So if I had a 3 in the front of this equation, instead of going up to 1, it would stretch it and it would go up between positive 3 and negative 3. If I was to have a 1/2 in front of the equation, it would squish it down and it would make it bounce between negative 1/2 and positive 1/2. So in these problems, a stretch or a compression is another word for what, do you think? Starts with an A. Amplitude. Yeah.
Oh, yes, ma'am.
So we don't talk about stretches or compressions. We talk about amplitude. So this is an amplitude of 1. It means it's not stretched or compressed at all. If I make it 3 times as tall as normal, then it's going to go up to positive 3 and down to negative 3. And we're going to say it has an amplitude of 3. So the number in the front we're going to say is amplitude. All right, and amplitude is just the distance that you are from the midline. So there's no such thing as a negative amplitude. What do you think a negative means? What does a negative normally mean in graphs? You flipped it, right? So a sine graph goes up first and then comes down. If we flip it, what's it going to do first? Go down and then come up, okay? So we're still going to say negative means reflect over x. Okay? All right, and then this b value, this is one that's completely different. We've never had this before. The b value changes the period of the graph. So the period of the graph is usually 2 pi. It takes a full circle to come back to the same number. So we go up and then we go down and we finish the rotation at 2 pi. The way that we figure out the new period of the graph is we do 2 pi divided by b. That's a formula. So if you can recognize what the b value is, you do 2 pi divided by that number, and that will tell you the new period of the graph. Okay, so we are going to practice some of these. The first one that we're going to do is y equals 3 sine of 2x. So 3 sine of 2x. We're not going to worry about left or right or up or down shifts today. We're just going to do amplitude changes and period changes. So if I have a 3 in the front, what's the amplitude of this graph? 3. And the formula to find the period is 2 pi divided by b. And the b value that we have here is 2. So I'm going to say my period for my graph is 2 pi divided by 2, which is pi. So the period of this graph is going to be pi. Okay, so we're going to start off drawing our dark lines just like we did before.
Oh, wow, this is a long box.
That's okay. And then I'm going to count 1, 2, 3, 4 boxes and put pi. 1, 2, 3, 4 boxes and put 2 pi. And this time our graph has to go up to 3, so I can't count 2 boxes as 1 like I did on the previous page. So I'm just going to count 1, 2, 3. I'm going to make each box equal 1 this time, just so that my graph will actually fit. That's what I did. Oh, if you do all the markings?
Yeah, like all markings.
That's fine.
Like lines of
That's fine. All right, so if we remember how sine graphs work, we start at 0, and end. We start at 0 and end at 0, and
In the middle.
hit 0 in the middle. And between the first 2 points, what do? We go up to 1. And between the second 2 points, we go down to 1. Okay. So for this graph, it has a period of pi. So we're going to start at 0. And it's going to end at pi at 0. So we start at 0 and end at 0. And then what do? Oh, wait, we start at 0, we end at 0. We hit 0 in the middle. So this one starts and ends in different places. Well, it starts in the same place, but it ends in a different place because the period is shorter this time. So we start at 0, we end at 0, we hit 0 in the middle. What are we going to do between the first 2 points? Go up. Instead of going up to 1, you're right, we're going to go up to 3 because the amplitude is different this time. So between the first 2, we go up to 3. Between the second 2, we go down to 3. And then we draw that nice kind of bowl shape, or you could call it a parabola shape. And then we'll do the pattern again. So we start at 0, we end at 0. We hit 0 in the middle. Between the first 2, we go up 3. Between the second 2, we go down 3. So we start at 0 and we end at 0. We hit 0 in the middle. We go up 3. We go down 3. Okay. How do we feel after that first one?
I don't like it.
Yeah, what's the question?
So when you got done with the first line, why did you do another one on that side?
Just because I had more space. I didn't have to. So typically they'll say you should do 2 full cycles of the graph. They don't specify you should do it to the right or left. Just show me that you can keep the pattern going. And I just felt like I had a lot of graph left, so I just kept going.
Right.
You don't have to do that. You do have to do 2 of them though. I do want to see 2 full cycles. Okay.
Okay.
So 1 full cycle was that.
1 full cycle is to the period, right?
Yeah, 1 full cycle is when you go up, go down, get back to your starting point. That's 1 full cycle.
Okay, and then that's why you went over.
Yeah, so I could have been like, there's 2, or I could have said, there's 2.
Okay.
You can do it either way. Or if you want to just keep going until you run out of graph paper, you could do that too. All right. What's the domain of the graph? Negative infinity to infinity. What's the range? Negative 3 to 3 with brackets. Okay. So, what's the amplitude of this one?
-2.
2. Now remember, the amplitude is always positive. What does the negative mean?
Flip. Just like that.
Yeah, it's going to be flipped. Okay. So amplitude of 2. To find the period of the graph, I think the way this one's written, it's a little bit hard to see what the b value is. So I'm going to rewrite it as y equals -2 sine, and x was being divided by 2. And if you divide something by 2, it's kind of like saying you have half of that. So what's the b value for this problem? It's 1/2. Okay. Taking x and dividing it by 2 as the same as saying that I've just got half of the x. So to find the period of the graph, we're going to say 2 pi divided by b. And what do I do if I have the fraction on the bottom?
You do keep it flip.
Keep it, change it, flip it. Mm-hmm. So the period of the graph is 4 pi. Okay. So we're going to draw our dark lines again.
Doing your count by 40.
Yeah, do you guys want to count 4 boxes to be pi again, or do you want to count differently this time?
Put it as 4 boxes.
You want to count 4 boxes? Okay. So we'll do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. All right. And then what do you guys want to do for the y values?
I do the 2. So you do 1 and then the very top one will be 2.
Okay. So, sine graphs start at 0 and end at 0, and hit 0 in the middle, and go up between the first two, and go down between the second two. Okay. So this one's flipped. Okay, you're right. So we're going to start at 0, and we're going to go all the way to the end. We're going to end at 0. And we're going to hit 0 in the middle. So we start at 0, we end at 0, we hit 0 in the middle. To do an amplitude of 2, normally we would say that in the middle of the first 2 points we should go up to 2.
But you have to go down because it's flipped.
But you have to go down because it's a flipped graph. So instead of going up and between the first 2, we're going to go down. And instead of going down between the second 2, what are we going to do? Go up.
So, for this graph, why don't we have as many points as we did?
We have less points because the graph is stretched out. The graph is stretched out to 4 pi, and since we made it, we still did 4 boxes. It just meant that the graph was like super stretched out.
So
It's like we took this and we like pulled it.
So for the one, this one. Okay.
So when the period is smaller, it squishes your graph horizontally. It's like you take an accordion and you squish it. And then this one, when your period is bigger, it's like you took the accordion and you pulled it out. And we have to do another period of the graph, another full cycle. So we start at 0, and we end at 0, and we hit 0 in the middle.
Go down first.
In between the first 2, we go down. In between the second 2, we go up. So what's the domain for this graph? And what is the range? -2 with brackets. Okay, we're going to make the next one more difficult.
No, wait a minute. I'm not finished. I'm kind of confused a little bit.
All right. Somebody give me an amplitude. 7. Sine. And this time we're going to do 5x. 7 sine 5x.
Shoot my graph over a little bit. That's okay.
Okay. We're going to go ahead and put the dark lines in the middle. Yeah, neither one of these numbers are great, are they?
No.
All right, what's the amplitude of the graph?
7.
7. What's the period for this graph?
2 divided by 5.
Yeah, so we always do 2 pi divided by b, and the b value this time is 5. So we have 2 pi divided by 5, and is that going to simplify to be like nice?
No.
So we just say, okay, the period's 2 pi over 5. All right, now here's what I like about these graphs. If you think about what we did before, I'll go ahead and draw it here since we've been drawing it every time. Whenever we do the sine, we always start at 0, and we end at 0, right? And we put 0 in the middle, so we always pick a number that can be like cut in half. That's why we've been doing 4 boxes, because you can cut 4 boxes in half. And then what happens between the first 2 points?
Go up.
We go up, and we do that halfway.
Yeah.
And then we go down, and we do that halfway. So we've been picking 4 boxes because 4 boxes can easily be divided into 4 sections. Does that make sense, why we've done that? Okay. So this period is not hard to graph as long as you put the 2 pi fifths at 4 boxes or 8 boxes or 12 boxes, something that's easily divisible by 4. So what I do is I just count 4 boxes, 1, 2, 3, 4, and I put 2 pi fifths right there and I call it good. Do you see how tricky that is?
Mm-hmm.
So the fact that it's a fraction 2/5 doesn't matter because I can still do my beginning point and my ending point and my middle. And I can still cut the first 2 in half and I can still cut the second 2 in half. So as long as I do it by 4 boxes, it's no harder to graph than any of the other ones were, even though it's a fraction. You guys see how I did that? Okay, so I'm going to count 1, 2, 3, 4. We got negative 2 pi fifths. Okay, our amplitude is 7. I'm going to go ahead and just say 7, 7.
That works.
I didn't cheat though. I'm not saying what each box is equal. I'm just saying the top is 7. Okay, so let's follow our pattern, right? So we start at 0 and we end at 0. Okay, so I start at 0 and I end at 0. And then what do I do in the middle?
Go up 7.
Wait. What do I do in the middle?
Zero.
Hit 0. And then what do I do between the first 2? I go up to 7. What do I do between the second 2? Go down. So, did it make a difference that I had numbers that weren't fun?
No.
Ultimately, no, it made no difference. And this is why it's really important that we label our graphs. Because if you're the one labeling your graph, you can make this as easy to graph as you want it to be.
So, the point from 0 to 2 pi fifths, that's the whole cycle.
Yep, start and end, right? And that's because they said the period was 2 pi fifths. So I just said this is where I end, this is the middle. And then I go up and I go down.
Miss Rhodes, would you can still figure out the range without graphing, right?
You can.
This is just
Mhm.
an amplitude.
Yep. So what's the domain for this graph?
Negative infinity.
Okay.
So that's what we've been doing this whole time, putting that dot in the middle because I don't know.
And the range, what's the range here?
Negative 77 in brackets.
77. Okay, we're going to do another difficult one. You guys ready?
No, we're going to make a number multiply again.
Not shit.
27.
Oh, please don't do twice.
I'm not sure.
How about we do
3.
4?
How
Okay.
about we just call it
We're gonna
2 and 4.
we're gonna do negative 4. I want to do another negative 1, and this time we're gonna do 1/3 pi x.
Wait, what?
What?
I'm very lost.
It's every single time. It is 2 pi on
It's
top
just pi.
divided by the b value. It's a formula. 2 pi divided by b every time. Okay. So. Yeah, it's pi over 3. Okay. So, what's the amplitude?
4.
What's the negative mean?
It means rubber. I feel bad for people that watch this movie. 30 minutes long.
How do we find the period?
Divided by 6.
2 pi divided by the b value,
Yeah.
which is 1/3 pi. That's what the b value is. What do you guys see that can cancel right now? The pi's. Those cancel, okay? And we keep, change, flip.
It's
So 2 times 3 over 1 is 6. So the period of this graph is 6. There's no pi in the period of the graph this time.
How do you?
You do it just the same, right?
Don't add the pi.
So you just don't put a pi on there. Okay, so let's go ahead and draw our lines. And the period of the graph is 6. That's along the x-axis. So how do you guys want to label the boxes on the x-axis?
3.
We want to do like 3, 6, 9. We want it to be real squished in there.
No.
Spread it out. Space it out. Okay. So we want each box to equal.
6 and 2.
So
Yeah, do every 2 blocks.
every 2 boxes counts as 1.
It's 2.
Okay, so each box is 1 then.
Yeah.
Okay. 2, 4, 6. 2, 4, 6. Okay. How about up and down, that amplitude of 4? How do we want to do that? The top is 4? Okay. So we're just going by ones this time. Okay. So let's remember how a sine graph works. We start at 0 and we end at 0. And we hit 0 in the middle.
Yeah, that's the point I be missing.
And between the first 2,
Yep, and up.
we go up to 1.
We go down.
Between the second 2, we
Go down.
go down to 1. Okay. So our our period this time is 6. So we start at 0 and we end at 6 at 0. We hit 0 in the middle, which is at 3. Okay. Now we have to be. Oh, did I miscounted? Good thing that was in pencil. There's my 6. Okay. Between the first 2, I would normally go up to 1, but I have a reflection. So instead of going up, I should go down. So between the first 2, I go down. Between the second 2,
You will go up.
I go up. And since we did 6 boxes instead of 4 boxes, we did have a decimal when we cut it in half again, and that's okay. We had to put something at 1.5. But it still works. Okay, so I start at 0, and I end at 0, and I hit 0 in the middle. And between the first 2, I go down to -4. And between the second 2, I go up to +4. And what is the domain? Yep, -infinity to infinity.
Wait, where?
And what's the range?